Good afternoon. Welcome to PCI's webinar series. Today's presentation is Make Your Bed, How Optimizing the Bed Preparation Process Can Change Your Operation. It's sponsored by Ultraspan. My name is Royce Covington, Manager of Member Services at PCI, and I'll be your moderator for this session. Before I turn the controls over to our presenters today, I have a few introductory items to note. Earlier today, we sent an email to all registered attendees with a handout of today's presentation. The handout is available now and can be found in the Handouts pane located near the bottom of the GoToWebinar toolbox. If you cannot download the handout, please email PCI Marketing at marketing@pci.org as shown on your screen. Note that all attendee lines are muted. The GoToWebinar toolbox has an area for you to raise your hand. If you raise your hand, you will receive a private chat message from me. If you have a question, type it into the questions pane, where I'll be keeping track of them to read during the Q&A period. PCI is a registered provider of AIA CES, but this presentation is non-CEU and does not contain content that is endorsed by AIA. Any questions about the content of this webinar should be directed to PCI. The program content does not constitute approval by PCI, nor does it necessarily reflect the views or positions of PCI or those of their respective officers, directors, members, or employees. Questions related to specific products or publications will be addressed at the end of the presentation. Our presenters for today are Judy Danielchuk. Judy is an experienced business professional with expertise in operations, finance, and business strategy and execution. She has been with Ultraspan for over 20 years, many of those years leading initiatives on efficiencies, cost savings, lean manufacturing, Six Sigma, and other activities that drive operational excellence. As part of her role as general manager, she leads the business performance team in charge of finding solutions that deliver quantifiable results to precast producers. As an advisory board member of the Manufacturers Association and serving on the board of various organizations, she is passionate about other businesses and thrives on their success. Joining Judy is Jason Fitzgerald, the Precast Solutions Manager for Ultraspan Technologies with over 14 years experience in structural consulting, project management, and precast plant operations. With extensive experience in the production of Holocore, wall panel, and other precast products, Jason works with producers to achieve optimal efficiency in both new and existing plants and has spearheaded the development of several automated plant expansions in North America. Jason remains committed to making automation technology more accessible to precast producers by harnessing the benefits of stationary process automation. I'll now turn the controls over so that we can begin our presentation.
Hello, everyone. Thank you for joining us today. First, a brief introduction to our company. Ultraspan is right here in North America and is part of the Progress Group with central offices in Europe, along with several manufacturing plants, service centers, and local presence across the globe. Our experience extends to over 55 years of continued support to more than 500 plants worldwide. Innovative technology and a unique in-house precast facility in Europe have contributed to position Progress Group as the leading supplier of technology for the precast concrete industry. In terms of numbers, we're the #1 machinery supplier in the industry with over 200 million euro in sales, over 650 employees, and customers across 76 countries. Here we see one of our customers, a precast plant in Thailand. They make product for 700 apartments per month and is one of the largest plants in the world. This Holocore plant in Belgium is fully automated with very low labor consumption. And here we see a double wall plant in Germany. In addition, we have over 50 plants here in North America. With that, I would like to extend a warm welcome to all of our attendees. Thank you for joining us. Also, a special thanks to our friends at PCI for hosting this webinar. I am also happy to have Jason with me today. Hi, Jason.
Hey, Judy. It's a pleasure to be here, and hello to everyone else who's listening.
So it's a big topic today. Lots of interest from the producers tuned in, I'm sure.
Absolutely. You know, I've visited countless precast facilities over the years, and the one topic that comes up all the time is bed preparation, especially in the stages right after previous production is stripped out. Lots of producers are facing challenges there.
So fair to say that producers have a hard time making their bed, right?
Exactly. Whether it's Holocore, double T's, wall panels, or similar, as long as there is a predominantly manual approach to cleaning, oiling, and pulling strand, there can be inherent operational difficulties.
But it seems like a fairly simple process. What could go wrong?
Well, to sum it up, it's either slow and tedious to achieve good quality, or fast and furious, leaving cut corners, which can show up later in the production cycle. It's kind of like when you're painting your house and you have to apply the painter's tape first. It can seem inconvenient, but it's such a critical step in the process to get right.
That's really interesting that you say that. And I'm sure with the ongoing labor crisis, it is not getting any easier. Well, hopefully today we can talk about some ways to help producers make their beds quickly and efficiently despite these constraints.
You bet. Let's get into it.
The objectives of today's webinar are twofold. First, to explore best practices for bed preparation. And secondly, we will be demonstrating how to leverage technology to maximize productivity in this part of the production cycle, as well as quantifying the major potential benefits. We will be covering 3 topics on our agenda. These are benefits of making your bed right, current industry standards, and solutions for optimization. Let's begin with our first topic, the benefits of making your bed right. As mentioned earlier, bed preparation is a critical step in the production process as it lays the foundation for the rest of the production cycle to continue. But we also need to think not just about the short-term process, but about long-term bed maintenance as well. Production beds and their components are a valuable asset. Without them, there is no process, and where maintenance lacks, quality suffers, affecting the viability of the production system as a whole. Bed maintenance is therefore a primary consideration to sustaining the production cycle. So where do we start? Cleaning is the first step, and this can happen immediately after previous production is stripped and loaded out, or sometimes even while it's still going on, depending on the type of product, space available, and scheduling. This can be a fairly labor-intensive operation, as we see here. Crews of 3 to 5 workers, or even more, can be involved on one single bed. The goal here is to remove all of the remnants of previous production cycle from all of the casting surfaces, including side rails and machine rails. This typically includes fragments of concrete debris, large and small, as well as dust, but may include leftover formwork and other scrap materials as well. Manual scraping, shoveling, sweeping, and vacuuming are standard practice here. It is no secret that this is one of the toughest jobs in the plant. Next comes oiling and finally pulling of strand. Once the bed is clean, the crew can begin to apply release agent, commonly referred to as oil, to the surface. This is done using a pressurized spray can or backpack, sometimes followed by floor mops. The key here is to apply a thin, even coat to all casting surfaces. Too little, and the product may bind in the form, causing damage to the product. Too much, and bug holes and other defects will be visible on the concrete surface. This is a very important job and is usually done by more experienced workers under the watchful eye of the QC manager, of course. The old adage, less is more, certainly applies here. Pulling the strands then takes place from one abutment to the other. There are a few methods used in the industry depending on the type of product, design of the beds and headers, and whether other reinforcement or headers are in place before strand is pulled. We won't get into all of the methods, but in general, a team of several workers are usually required to pull the strands off the coils and walk them to the other end of the bed with or without mechanical assistance. This can be quite a tough job with high risk of injury from slipping on the freshly oiled surface. I would like to turn your attention for a moment to looking for opportunities for improvement. I am sure that most of you here are familiar with the 8 types of waste commonly affecting production systems, better known as TIM woods. They are transportation, inventory, movement, weighting, overproduction, overprocessing, defects, and skills. In the context of this stage of bed preparation, the most prevalent source of waste are transportation, movement, weighting, defects, and skills. Our intention is not to explain this in detail, but to provide you with the information to recognize where waste can occur. I am sure that every producer can relate to several of these in their plant. Solving value leaks through eliminating these wastes are the cornerstone of continuous improvement and the key to unlocking the full potential of production efficiency. When assessing the elements of TIM woods, lean methods, efficiencies, and financials, 3 simple areas to also check are cycle time, labor, and rework. You can use the acronym CLR to remember these simple steps. Cycle time represents the total time from the beginning to the end of a process that includes both process time and delay time waiting to take the next action within the process. When looking at the costs associated to cycle time, there are many elements to consider. These include the availability and use of overtime, shift scheduling, scheduling efficiency, weather delays, material planning, and logistics. It is also important to note that the costs not only include the direct cost of the process, but also indirect or hidden costs, where a higher cycle time can mean higher costs associated to these elements, increasing costs to the business. Safety is also an important element to consider in cycle time. Injuries or safety violations can cause delay in the process, increasing the cycle time. In the 2018 Workplace Safety Index, Liberty Mutual estimated that employers paid more than $1 billion per week for direct workers' compensation costs for disabling, non-fatal workplace injuries. The L in that simple acronym CLR stands for labor. What are the costs associated with labor outside of the direct wage cost? The cost of hiring and onboarding and training, turnover, demand for skilled labor, professional development, associated administration costs, injuries and illness, and more recent costs of social distancing. According to a training industry report from Training Magazine, the annual training budgets of U.S. small businesses totaled an average of $308,000 per year. The cost to replace a high turnover, low paying job is 16% of their annual salary, and the cost to replace a mid-range position is 20% of their annual salary. I know that for many of us, the cost to replace personnel is actually much higher than 20%. In some cases, the cost to recruit alone is 20%, plus the additional cost to train and onboard. This, in the end, makes the impact of labor a critical factor in profitability in business. The third area to check is rework, which represents things that need to be redone or worked over again and done right. I love this image here as it is a perfect representation of why we want to avoid rework. You can spend all the time and money to design, build, and in this case, install the staircase, but in the end, it doesn't take us anywhere. There are many cost implications to rework, including labor personnel and labor time requirements, cost of wastage and disposal, customer satisfaction, quality control, impact on schedule, transportation costs, and impact on morale. According to the American Association of Quality A general rule of thumb is that costs of poor quality in a thriving company will be about 10 to 15% of their operations. Effective quality improvement programs can reduce this substantially, thus making a direct contribution to profits. And so I hope this was a helpful reminder that we can continue to get excited about finding opportunities for improvements in operation. So now I will hand this over to Jason to present the next part of the webinar, beginning with current industry standards.
Thank you, Judy. So in the industry, the bed preparation process typically follows the process that we see here on the screen. It's a three-step process: cleaning, oiling, and pulling strand. In the non-mechanized plants where manual processes are used, the methods will look just like what Judy described a few moments ago. All of these steps require a labor component with at least a basic to intermediate skill level. These steps are critical and need to be executed quickly and on time for successful handover to production crews, regardless of the type of product. So let's take a quantifiable look at some industry standard benchmarks for cleaning for Holocore, wall panel, and double T. This table shows the labor cost for cleaning for 1 million square feet of production for all three types of product. This shows that with a cleaning crew of 4 to 5 workers, each paid at the going rate of about $30 per hour all in, you would expect to pay somewhere between 3 cents and 10 cents per square foot produced, depending on the product type. This tends to be higher in the wet cast production, such as wall panel and double T, than in dry cast Holocore. This is because of the casting method and the fact that overfilling of the forms tends to produce more cleaning activity as a result. This might seem like a small amount at first, but this can add up to over $100,000 annually. And this is just for 1 million square feet. So it will scale up with higher production volumes. I would invite at this time all producers who are tuned in to take note of these numbers to see how your production measures up. If you're out of this range on the higher side, it might be time to look at improvements to your process. If you're under, congratulations, you're doing something right. Moving on, let's look at oiling in the same way. Oiling crew sizes are typically smaller with between 2 and 3 workers. Remember, these are the more experienced guys, and typically for wall panel, they'll have 1 person with a mop to make sure that it is applied evenly. For double T's, you'll have to oil the deck in 3 places and the stems as well. So there's a lot of surface area to cover there. For Holocore, there are typically 1 to 2 workers, 1 with a spray can and the other with a squeegee. For oiling, you'll expect to pay somewhere between 1 cent and 5 cents per square foot produced. This equates to between 10,000 roughly and 45,000 per 1 million square feet, depending on what you're producing. So you can see how this is starting to add up. And finally, we're pulling strand, and this is where we see a lot of variability between the processes in the field, because some producers use mechanical assistance like what you see here in the photo on this double T bed. But for manual strand pulling, the numbers look like what you see here on the slide, where producers can spend between 2 to 3 cents to as much as 8 cents per square foot for pulling strand. So a summary of the complete preparation cycle for manual processes for all 3 product types. You can see it here summarized in this table. So for Holocore, complete cycle, which includes cleaning, oiling, and pulling strand, we expect to see about just over 1.25 hours per bed. Wall panel is just under 2 hours per bed, and double T can be as much as 2.5 to 3 hours. The annual cost of labor for cleaning is about $30,000 for Holocore, $100,000 for wall panel, and about $37,000 for double T. For oiling, it's just under $10,000. For wall panel, it's about $45,000, and for double T, it's about $15,000. And finally, for pulling strand, for Holocore, it's approximately $22,000, wall panel $80,000, and double T about $30,000. So all of these add up to approximately $62,000 for Holocore, $225,000 for wall panel, and $82,000 for double T, for a total cost per square foot of 6 cents for Holocore, 23 cents for wall panel, and 8 cents for double T. This is again per 1 million square feet produced. Again, these are industry standards and may seem a little bit on the high side in some cases to some, but if so, that's good news. It means that you're doing better than average. If not, then it might be time to look at optimizing your process. So other than the quantifiable view of the production preparation, what are some of the common problems that we see? The common problems that we see start with the delays affecting the cycle time, which is the length that the production takes in total. This can lead to excessive overtime, and then also a lack of consistency in cleaning and oiling. This also leads to rework in the final product, and also a high worker turnover and absenteeism. And at worst, you can also see issues with injuries and lost time claims as well. So these are some of the intangibles and unquantifiable issues with bed preparation. So on to optimization solutions. So with the advance of precast automation technology for long bed systems, producers can integrate equipment into their operations to assist with cleaning, oiling, and pulling strand. These machines will typically run on rails beside the bed or on the forms themselves, and can be transferred from line to line so that the investment can be utilized throughout the complete production system. So let's take a look at automated bed cleaning solutions, which can take care of the heavy lifting, scraping, sweeping, and vacuuming that Judy was talking about. These types of machines are able to loosen and clear the concrete scale and debris, clean the fixed side shutters on the production bed. Dust collection systems, which are compliant with OSHA and silica standards, are also available on these machines. Cleaning the form surface using scrapers and horizontal brushes. The main brushes can also be lifted to avoid obstructions on the bed, which is important for wall panel production where we have bulkheads that we need to clear. We can accommodate different types of bed surfaces through the use of different types of bristles, such as Teflon or steel, depending on what's required. And we can also have pivoting side brushes for side shutter cleaning. And in the case of double T, we also need to take care of the stem cleaning, and this is done through the use of stem brushes on these types of machines. Let's take a look at what the impact of these types of machines would be. In this case, for Holocore, wall panel, and double T, we can see a drastic reduction in cycle time per bed for each type of product. We will show a summary slide at the end of this so that we can see everything compared together to the manual processes. But right off the bat, we can see shorter cycle times and a lower number of employees required to conduct the bed cleaning operation. We can also see lower costs in total for cleaning, obviously, with about $5,000 per year for Holocore, just under $10,000 for wall panel, and just under $4,000 for double T. Again, this is on the basis of a million square feet of production. This equates to a cost per square foot of approximately ½ of a cent in Holocore, 1 cent for wall panel, and 4/10 of a cent for double T. It's quite a difference. Then on to automated oiling. So along with automated cleaning, bringing in an automated oiling machine can have expanded benefits to production as follows. We can have optimized oil application across the bed surface, PLC-controlled pressure systems, which allow control over the nozzle system and application of oil, customizable oil temperature control, ensuring consistent results across a wide temperature range, sectional oiling, ensuring effective application of oil over the bed surface so that you don't overuse oil in areas where you don't need it. And you can also have customized application to achieve optimal results with a wide range of different types of oils, ranging from mineral oils, synthetics, as well as water-based oils as well. So the impact of bringing in an automated oiling system are seen here. So just like in the slide before, we can see a reduction in cycle time per bed for each type of product. Again, and a reduction in the number of employees required because there's only a single employee required to run this type of machine. A large reduction in annual labor costs for oiling. So for Holocore, we're looking at about $1,500, $4,800 for a wall panel, and approximately $1,200 for double T. The cost per square foot to produce 1 million square feet is down to about 0.2 cents for Holocore, 0.5 for wall panel, and 1/10 for double T. You can see that these are extremely low, but in some cases they're actually inflated and could effectively be zero if the oiling is done while cleaning is happening, which is possible with these types of machines. If not, it's done during a return run and the costs are tracked as you see here. So it could be less or it could be as you see on the slide. And finally, with an automated strand pulling machine, producers can pull multiple strands simultaneously rather than running up and down the bed with multiple workers. You can also have quick release locking mechanisms on the strand towing equipment so that you can thread the strand through the bulkheads while you're pulling. And also you can have adjustable torque settings so that when you're pulling out of the strand cages, you can prevent snagging or hang-ups when you're pulling out the strand from the strand packs, which is a huge benefit when you're pulling multiple strands all at once. So with automated strand pulling, here we see the impact of this type of machine. So again, reduction in cycle time per bed, significant compared to the manual processes. Approximately 2 employees required. You usually will require at least 1 employee on the machine and 1 on the strand packs as well. And everything being equal, you'll be looking at about $7,500 a year for Holocore, just under $20,000 for wall panel, and just under $7,000 for double T. The cost per square foot equates to about 1 cent for Holocore, 2 cents for wall panel, and again 1 cent for double T per million square feet produced. So if you look at the automation results all summed up together, the complete cycle time per bed is about 0.7 hours for Holocore, 0.8 hours for wall panel, and just over an hour for double T. The total annual labor cost for cleaning for Holocore is about $5,000. For wall panel, it's just under $10,000. For double T, it's just under $4,000. For oiling, again, $1,500, $4,800 for wall panel, $1,200 for double T, $7,500 for Holocore. For pulling strand, wall panel is about $20,000, and double T is about $6,700, and that's for pulling strand. So the total annual cost for bed preparation, summing this all up, is just under $14,000 for Holocore, approximately $35,000 for wall panel, and about $11,700 for double T. So all of this equates to about 1 cent for Holocore, 3 cents for wall panel, and about 1 cent for double T per square foot per million square feet produced. So let's look at the savings. So we summarized the costs for the manual process. We've also summarized the costs for automated processes. So here we can see the comparison. So here we have Holocore. We are saving about 0.6 hours in cycle time per bed. For wall panel, it's approximately 1 hour. And for double T, we're saving about 1.6 hours. That's a huge difference if you look at the overall production day. That's the difference between having a regular day and having a significantly overtime dominant day. Also, in terms of dollar value, we've saved in terms of Holocore just under $50,000 per year. For wall panel, about $190,000 per year, and double T we've saved about $70,000 per year, again for 1 million square feet produced. Comparing this on a graphical basis, we can see here just per bed the manual process for Holocore. This is all summarized for the complete process. This includes cleaning, oiling, and pulling. The manual process on the left, about approximately 4 workers on average, taking approximately 1.3 hours to complete the production process for bed preparation, with a total of 5.2 man-hours worked for that process in the manual case. And on the right, I don't need to explain it too much because you can see it here. There's a huge reduction in overall labor and man-hours for preparation using an automated solution for Holocore. Similarly, for wall panel, we see again the manual process on the left, approximately 4 workers engaged, total time of 1.8 hours, and 7.2 hours of total labor used in the manual process. In the automated process, we've barely used 1 hour in terms of man-hours. There's a huge difference here between the manual and automated processes. And again, here for double T, approximately 10.8 man-hours used in the manual process and just over 1 hour used in the automated process. Quite impactful information. So finally, in summary, I think we've demonstrated here today that for manual bed preparation, it can be quite tedious and labor intensive depending on the type of product and the process that's being used. And it's certainly prone to errors and labor quality issues. By introducing automated bed preparation, we can reduce the cycle time and labor components for cleaning, oiling, and pulling strand quite significantly. This will improve quality and reduce rework for the producer, resulting in better plant safety and higher profitability, competitive advantage, and customer satisfaction. With that, this concludes our presentation, and I turn it over to PCI.
Thanks, Judy and Jason, for a great presentation. We have a few questions, so we're going to just jump right into our Q&A session. The first question is, are these machine widths adjustable for plants with multiple different size beds?
So the answer is yes. Most of these machines are able to expand and contract depending on the requirements of the production system. So for example, if you had one bed which was in the context of wall panel, say 10 feet wide, and then you had another one adjacent which was 12 feet wide, it's possible that these types of machines could accommodate adjustment in width for running on different rail spacings. So yes, it is possible to do what you're asking.
Excellent, thank you. I have a two-part question. This next one is, what are the available power options, and is cable-free operation an option?
So the answer to this is yes. There are various power options depending on what's available on site. You know, you can have 3-phase power, 480 volt, 400 to 480 volt. Other options as well. It's possible to run this through a conductor rail system or a cable reel, if that's an option. Battery power is also a popular option with these types of machines, as well as petrol-driven options such as diesel and other types of options like that.
Okay. The next question is the machine customizable to include bed marking?
The answer is yes, depending on the type of production. Plotting can be added to the functionality of the machine. In the case of, say, a producer who needs to clean, oil, and then plot the bed, the plotter can be an additional function on the machine as well, yes.
Excellent, thank you so much. We have a question that came in. It says, how do you ensure the oil is sprayed evenly?
So there's a couple different ways, but first it begins with the design of the machine. So when we're working with producers, typically what we do is we get a sample of the type of oil that's going to be used, and we optimize the spray system to function specifically with that type of oil. So that means, you know, testing the results of the spray system before it's used in the plant. The other thing that's done is the reservoir of oil is heated to an exact temperature, depending on the requirements of the oil, so that whenever it's sprayed, it's always at the same temperature and therefore atomizes in the same way on every application. So therefore, the result is typically the same on every pass.
Okay. That's all the questions we have, unless anyone wants to send one in right now. I'll give it a few seconds here to wait for some questions. See if anyone else has anything else that they would like to know. Well, it looks like that's all the questions that we will get today. If our attendees are looking, if you would like more resources and information, please go to www.ultraspan.ca. For more information, you can reach out directly to them and they can give you more information that you may need. On behalf of PCI, I'd like to thank our presenters for the great webinar and all our attendees for your participation. Today's presentation will be uploaded to PCI's e-learning site within 3 business days. There will also be a pop-up survey after this program ends. If you have any further questions about today's webinar, please email marketing@pci.org with the title Online Bed Webinar. Thank you again. Have a great day, and please stay safe.